Okay, this is 8th grade lesson 6.3. Our objective today, students will approximate square roots as being between two integers. The standards covered in this lesson are 8NS1 and 2 and 8EE2. The page numbers out of the hardcover book are pages 244 through 251, and out of the practice journal, pages 125 through 129. To begin our lesson, we're going to start reviewing what a rational versus an irrational number is. So a rational number is any number that can be written as a ratio. Remember, a ratio most commonly would be like a fraction. That is considered a ratio. So any number that can be written as a fraction is considered a rational number. So for example, all whole numbers, for example, 5, can be written also as a fraction by writing it over 1. So all whole numbers, also known as natural numbers, can be written as ratios. Also integers. Integers are going to be those natural numbers or those whole numbers and their opposites. So -1 could be written out as -1 over 1. That can be written as a ratio. Also, other rational numbers will include any fractions, which we already discussed, and any decimals. So in order for a decimal to be considered rational, it either has to terminate like this one does. It ends after the 5, or it has to be a repeating number. So like here we have 0.3 repeating, but even if we had something like this and it showed all 3 of those repeating, then that is considered a rational number. Irrational numbers, on the other hand, are going to be what I would call those crazy numbers. If I asked you to memorize those, you would say you're crazy. Those are numbers that never end. They're non-terminating. Okay, so some examples of irrational numbers would be pi. Now we use 3.14 for pi, but that's just a rounded number. Pi is actually a non-terminating number that continues forever. Also, non-perfect squares are going to be irrational numbers if they cannot be broken down any further. Now, if you had 0.6 underneath, 0.36 underneath, well, we can find the square root of 0.36, which would be 0.6. But if you have non-perfect squares that can't be broken down to a decimal number that terminates, then those are also considered irrational. Okay, the square root of any whole number that is not perfect, a perfect square, is irrational. And we already discussed that, like 2. Also, the decimal form of an irrational number neither terminates nor repeats. So those decimal forms of irrational numbers are those ones that I said to you earlier, continue forever. So pi continues forever. Oops. Okay, so we're going to go ahead and practice identifying whether a number would be considered rational or irrational. So the square root of 12, if you were to check that on your calculator, first of all, it's a whole number underneath of there that is not a perfect square. So that would be considered irrational. If we were to actually check to see what that number looks like, it's actually 3.464101615, and that's all my calculator actually shows. So that number would continue forever. So non-perfect whole number squares would be considered irrational, and that's why, because 12 is not a perfect square. Okay, so the next one, we have -0.364 with the 4 repeating. So the 4 is repeating. That would be considered rational. If I were to ask you to memorize that number, you could say, yeah, I could do that. I would just have to remember to continue to say 4 over and over and over again. Okay, our reasoning is because it's a repeating number or a repeating decimal. Okay, the next one, we've got 1 3/7. So we have a mixed number. Remember, any number that can be written out as a fraction, which is a ratio, is considered rational. So this would be considered a rational number, and that's because it is written as a mixed number. It falls between, or it can be written out as an improper fraction of -10/7. Okay, so why don't you go ahead, or we'll do this next one together, and then I'll pull another one out. So 0.85, it terminates, it ends. That would be considered rational. Why? Because it's a terminating number or a number that ends. It could also be written out as 17/20, which is the ratio form of 0.85. Okay, so we're going to go ahead and have you guys try these 3. So it says, tell whether the number is rational or irrational and explain why you chose that. So go ahead and pause your video. On your whiteboard, write 1, 2, and 3, and then identify whether you think these are rational or irrational, and you can just use R for rational and I for irrational, and then check back on your video when you're finished. Okay, so here we got for number 1, we had an irrational number. And one thing I forgot to go over earlier is anytime you have these 3 dots, that means that that number is going to continue forever. Not as a repeating number, but it's going to continue to go on forever. So those 3 dots mean a non-terminating number. Number 2, the square root of 196 is 14, so that would have been a negative 14. So we did get a rational number there. And number 3, 2 as a whole number is not a perfect square, so that is also considered irrational. Okay, rational numbers we can write as ratios, fractions in other words, perfect squares, and then any decimal number that either repeats or terminates is a rational number. Irrational are those crazy numbers, those numbers that never end. Those would include pi and non-perfect whole number squares. Okay, so we're going to go ahead and work on approximating square roots. I know some of you have come across these on STAR previously, and it's actually a very easy concept to do even without your calculators. I know some of you will use your calculators, but for right now, I want you to practice this concept just so that you can understand how to do it even if you didn't have your calculator. Okay, so when approximating squares, we're going to find the 2 perfect squares that the number would fall between, and then we're going to decide which radicand number it is closest to estimate it. So it says estimate the square root of 52 to the nearest integer. Okay, so I'm going to shove this off to the side. Well, no, I'm not. I'll just leave it. So if I were to go through and do this, I know in my red writing there, I'm kind of explaining what I'm verbally going over right now. If I were to think of my perfect squares, which I have written off to the side here, well, 52 would fall between these 2 numbers right here. So if you're somebody that needs to maybe jot down these perfect squares so you have a really quick reference, that's okay. But remember, perfect squares are your basic multiplication facts where you're taking a number times itself, okay? So when I go through and I see 52 would actually fall in between these 2 right here. Well, it would fall between 7 and 8. The square root of 52 would fall between the numbers 7 and 8 on the number line, okay? So now, which is that closest to? Because they really want us to estimate it. Well, I can tell you right now, I know some of you have been getting questions like this where they'll say, between what 2 consecutive numbers does the square root of 52 fall? So understanding here that when you think of your perfect squares, it falls between 7 and 8. Okay, so 52 is closer to the 49, right? It's 3 away from 49. So if this was the square root of 49, these are 3 away from each other. And this was the square root of 64. These are 12 away from each other. Okay, which one is it closest to? Well, it's closest to the 7. So an estimate is the square root of 52 is about 7. Okay, it's a little more than 7, but it's pretty close to 7. Okay, so we're going to go ahead and practice some of these. And like I said, if you need to jot down those perfect squares so you have them to reference back to, you can do that. Right now, you've got them available too. So it says estimate the square root of 85 to the nearest integer. So 85, well, let's see. That would fall between 81, which is the square root of 9. Or sorry, the square root of 81 is 9. So it would fall between 9. And then we would have the square root of 85. And then the next perfect square is the square root of 100, which is 10. So it falls between 9 and 10. Which is it closest to? Well, here we're 4 apart. And here we are 15 apart. So which is it closest to? It's closest to 9. So the square root of 85 is about 9. Okay. Key thing is I'm going to have you guys practicing what 2 numbers it would fall in between, and then also which number is it closest to. I know the book is going to ask you to go to the nearest tenth. I'm just going to ask that you understand how to get to the nearest integer. If you want to practice going to the nearest tenth, that's okay, and then you can kind of check yourself on your calculators if you need to. Okay, so let's go ahead and try another one of these. Okay, the square root of 190 to the nearest integer. So now, if you look at my perfect squares, I didn't go all the way out to 190. So I'm going to have to extend this out a little bit. I've got all the way out through 12. So if I were to do 13, well, that would be the square root of 169. And 14, I think, is 196. Let me double check myself. Is 196. And then 15 would be, I think, 225. Yep. Okay, and that's far enough for me now. So now what two numbers would that fall between? Well, 190 would fall between here, the 13 and the 14. So the square root of 169, which is 13. And then we would have the square root of 190. And then we would have the square root of 196, which is 14. So it would fall between the numbers 13 and 14. And it is closest to 14 because here there is only 6 difference, whereas here there's 21 different. So it's closest to 4. So the square root, 14, of 190 is about 14. It's a little under 14, but it's about 14 if we're estimating them. Okay, so we're going to go ahead and have you guys try one of these. Once again, using those perfect squares. Okay, estimate the negative square root to the nearest integer. So anytime they give you that negative, don't worry about that. Remember, all of our square roots are going to give the same number. It's just that we're going to throw a negative in front of them on our final answer. So if we were to find the negative square root of 7, well, let's just think if it was positive, where would it fall? Well, square root of 7 would fall in here, right? So it would fall between the square root of 4, which is 2, and the square root of 9, which is 3. Which is that closest to? Well, it's 2 away from 9 and 3 away from 4. So it's closest to 9. So the square root, negative square root of 7 is about -3. Because I have to remember that these are working the negatives since they have this little negative symbol in front. Okay, and you can just add that on into your answer in your final step. But just understanding that it's closest to 3, or it would fall between -2 and -3 on the number line. Okay, so I want you guys to try this one. Estimate the square root of 33 to the nearest integer. So the square root of 33. Go ahead and pause your video. Find, first of all, what two integers it would fall between, and then identify which one it's closest to. Okay, so it would fall between the numbers 5 and 6, and it is closest to 6, so the square root of 33 is about 6. Okay, because it was 3 spots away from 36 versus, 8 spots away from the 25. So it's closest to 6 here, or it would fall between the numbers 5 and 6. The way that I've been seeing a lot of you guys get them on STAR is it asks you to identify this versus about how much it is. Okay. Remember on Iowa assessment, when you get to this part, it may be on the part of the test that you can't use a calculator. So make sure that you're comfortable with that concept. And perfect squares are pretty easy to work with. Okay, the last thing that we're going to go ahead and go through, or one of the last things, is just comparing real numbers. So we kind of did that on the previous slide, just saying where would it fall in between. This time what they're going to do is they're going to be asking us to compare or identify which one is greater. So here it says, which is greater, the square root of 5 or 2 3/4. So the first thing is to understand where would the square root of 5 fall. So kind of doing what we just previously did, square root of 4, and then the square root of 9. It's pretty close to 4, right? Because square root of 5 would just be one number difference. So that's why they identified it here. Now, if you would like to use a calculator for this part, I would be okay with that. I think they still want you approximating the squares. Okay, so now if I were to look on the number line, well, which is bigger? Are 2 3/4. Or if they ask us to compare, it would be like that if they had them with an open space between it. Okay, so let's practice some of these. Once again, approximating those roots, paying attention to symbols. Okay, which is greater, 0.6 repeating or the square root of 0.36. So square root of 0.36, if you want to go through and use your calculator for that, it's okay. This is the same as 0.6. So if they were to ask us, and I think on your worksheet it asks you to compare them like this, and that's repeating. Okay, which is bigger? Well, this is the same as 0.66, and this is the same as 0.60. So now which is bigger? The repeating number is bigger. So anytime you have digits that are the same and one's repeating, the repeating number is bigger, unless they throw a negative sign in there. So 0.6 repeating is bigger than the square root of 0.36. So you're going to solve first for those square roots and then go from there. Okay, so square root of 23 is really close to square root of 25. So this one's really close to 5 on the number line. And this is going to be closer to 4 on the number line. So which is going to be bigger? The square root of 23. And if I want to check that, I could change both of them to decimals too. 23, the square root is 4.79. And 4 1/5 is 4.2. So once again, if you prefer to see them as a decimal, you could also compare them that way. Okay, so comparing again, which number is greater, the square root of 10 versus the negative square root of 5? So here they're giving us two square roots that are not perfect. Okay, the first thing I look at here is I'm noticing there's a negative in front of this one. I don't even have to convert these into their decimal or anything or approximate them. I know that the smaller number is the negative. So if I were comparing this and I had this written out like this, and then comparing to the negative square root of 5, that negative is already making it smaller, so my open mouth would go that way. Or the square root of 10 is greater than the negative square root of 5. Okay, so I want you to try this one. You have the negative square root of 2, and then compare that to 2. Which one is greater? Key thing to remember on this one is you are working negative numbers. So remember that negative sign out in the front means the opposite. So normally, if I was just comparing these as whole numbers, I would say that the 2 is bigger than the square root of 2 because that's obviously going to be like 1.4 or something like that with a long number. Okay, so you have to remember, because you're working negative numbers, the bigger the digit, the less it's worth. So which is greater? Our negative square root of 2 is actually greater because it's in the negative set of the category. It's actually closer to 0. If I was looking at my 0 line, here's negative 2, and negative square root of 2 would be like at 1.4 if this was 1. Okay, negative 1.4, this would be my square root of negative, or my negative square root of 2. Okay, so it's bigger because it's closer to 0. Or not closer to 0, but further down the line on the right side. Okay, so that's working with comparing some real numbers. The last thing is just working some real world application and where they might give us some story problems working with those square roots. So it says the distance in nautical miles you can see with a periscope is 1.17 times the square root of the height, where the h is the height of the periscope above the water. Can a periscope that is 6 feet above water see twice as far as a periscope that is 3 feet above the water? Explain. So I put in here, go ahead and use your calculators to do the distances. So we're going to go ahead and use this equation for both of these. So for the first one, where h is, we're going to substitute a 3. So 1.17 times the square root of 3. And then for our other one, it's still 1.17 times the square root of 6. Okay, so when you solve these, you have to do your square roots first. And we're going to go ahead and actually get the actual answer. Okay, so the square root of 3 is 1.7, a really long number. And then we're going to take that times 1.17. And when I do that, I get 2.026. Okay, so now I'll go ahead and do this one. So I need to do the square root of 6 times 1.17. And when I do that, I get 2.865. Okay, So the question was asking, can the periscope that is 6 feet above water see twice as far? Is this doubled to get our 2.865? No. So that would be a no. Why? Well, because it only sees, what, about 0.8 nautical miles further. Okay, so no, it did not double it. Okay. Last question. It says you use a periscope that is 10 feet above the water. Can you see farther than 4 nautical miles? So here we're checking to see, will it see further? So what's your guess based on the fact that we were at like 2.87 approximately for 6 feet? So do you think at 10 feet that it will? Well, let's go through and check it. So we're going to plug in 10 here. So we're going to do the square root of 10 times 1.17. And when I do that, I get 3.69. Repeating, or about 3.7. So can it see farther than 4 nautical miles? No, it's still only a little above 3.5 miles. So that's it for this lesson, working with approximating roots, and then also working with some non-perfect roots. Key thing to remember here is that when you're working your way, your way with approximating, make sure that you work with those perfect squares and finding those 2 consecutive numbers that it falls between. I know that that's something that is showing up on STAR, so I want you to get comfortable with those.